Okay, so let's say we had, this is our vector here, this arrow, right? We said V with a little arrow over top of it indicates that that's a vector. We said the x component is V sub x, y component is V sub y. The direction angle is theta sub V if the vector is V. But again, V, not every vector has to be a V. You can have W or T or R. It's just a variable. Okay? Okay, and then we said the length of the arrow is called the magnitude of vector V. Cool?
Mm-hmm.
Yeah.
You're taking notes on your hand?
No, I'm just reminding myself.
Okay. Like this, you're gonna need a lot more hand. Okay, so we said that this vector could be written as the x component, comma, the y component, or it could be written as, right, and you should have this in your notes already, so it's just a recap. Magnitude, cosine of direction angle, comma, magnitude, sine of direction angle, where the direction angle starts at the positive x-axis and rotates counterclockwise. So this should be in your notes already.
Wait, can you say that again? The counterclockwise.
So when you do an angle, it starts, this is 0, the positive x-axis is 0, and you rotate this way.
Yeah, it's wherever your line, to wherever the line is.
Yeah. All right, now we didn't say, so this is how to resolve a vector into its two different components. So if you have the magnitude and the angle, you can plug them into that and boom, you get your components. What if you don't have the magnitude and the angle, but you have the components? And you need to go backwards.
Filthy algebra.
Filthy. Dirty algebra. Well, check it out. If I had this and this, if I had the components, the x component and the y component, and I wanted to find the magnitude,
That's just like slope.
You just do sine.
or, I mean, yeah, kind of, but, or,
Trigonometry?
the length of this is not a slope. What is the length
Yeah.
of a hypotenuse on a right triangle? Help me.
A squared plus B squared.
Yes.
B squared.
It's a Pythagorean theorem.
Oh.
So, you know this.
Perfect. Yeah.
So there's some math that's, a lot of it's like scary notation, but the math isn't always that bad, really. It's just there's going to be a learning curve of finding out like what all this notation means. You're like length of arrow, angle of it. You know, like once you get used to it, it's not rocket surgery. So let's write a formula for the magnitude. The magnitude of vector v. If we do the a squared plus b squared equals c squared, but then we have to square root both sides, we'll find out that it's the square root of the x component squared plus the y component squared. Right? That's your Pythagorean theorem in vector notation.
Yes.
Okay.
But that's straight up a squared plus b squared.
B squared plus B squared.
Yeah?
Yeah.
I'm nervous.
So this is c is equal to the square root of a squared plus b squared.
Yes.
But instead of a and b being the legs of our triangles, now it's v sub x and v sub y. The x component of this vector and the y component of that vector. So again, this looks super impressive. Like that could be my next tattoo. People will be like, man, he's smart. But that's the Pythagorean theorem. Right? Not a big deal. Okay, also, let's say I wanted to solve for this angle and I know these components.
Oh, yeah. Sine angle.
The inverse, what?
Inverse
tangent. So the tangent of theta sub v is v sub y over v sub x. So if I do the inverse tangent, that'll solve for this direction angle. It's the inverse tangent of the y component over the x component. Bam. So these are your basic formulas here. Basic. Yeah, this is basic. This is baby stuff. This is, you know.
Okay.
Basic. Yeah, this is basic stuff. So this is resolving a vector into its components. Here's finding the magnitude or the length of it, the length of the arrow. Here's finding the direction angle. So the angle of your arrow from the x-axis. So that's that. Now, I'm going to say a bunch of more things about vectors. There's so much. And I didn't want to give it all to you last class because your head might explode. But so we're getting used to it. We're seeing that this isn't too bad. It's a little geometry, a little trig, a little, no big deal. Now I'm going to tell you that a unit vector, we'll write a definition of this. So a unit vector, a unit vector V, now instead of putting an arrow over it to indicate that it's a vector, we're going to put a little hat on it to indicate that it's a unit vector. A unit vector V hat, and that's what it's called. It's called V hat.
Really?
I mean, this little symbol is called a circumflex. But that's too much. That's too far. It sounds like a penis or something. So a unit vector, this is called V hat. It's called V hat, or sometimes they call it V cap. But all my professors called it V hat, and I've only ever called it V hat. So, but it's V cap, same
They
thing.
said V cat.
This is probably like in Europe or something, where they wear caps and eat biscuits, like whatever. Anyway, so a unit vector V hat is a vector with magnitude 1. We could say this: the magnitude is equal to 1. That's hence the name unit vector.
Do we have an example of that?
Yeah, so we'll say, and also you can, you're going to get some examples, don't you?
Oh, okay.
How about, I'll keep writing. You can find a unit vector in the direction of any vector. So to find a unit vector in the direction of, how about we'll use W as another vector, just so you're not scared of using different variables. So to find a unit vector in the direction of this arbitrary vector, some vector W, divide it by its own magnitude. That's not the apostrophe. Its own magnitude. And this is pretty slick. You have a vector, if you divide it by its own length, it becomes 1. Right? Like something divided by itself is 1.
Uh-huh.
So when you see this as a vector, you're like, that's super slick. So let's say W is some vector 3, 4. Those are the x and y components. So this is a 3 and this is a 4. What do you suppose the length of that the magnitude of that vector is?
5.
Yeah, it's a 3, 4, 5. So the magnitude is 5. So if I wanted to find a unit vector, I would take this guy and divide it by its own length, which is 5. And so what that means, if I'm going to divide a vector by something, you divide each of its components by that something.
Okay.
Just like if you wanted to multiply a vector by 2, you would double each of its components.
So then the unit vector of W is 3 over 5, 4 over 5.
3/5.
Boom.
Which is...
And so that'll be a vector that goes in this direction, but it has a length of only 1. It's a little nubby vector. And if you were like, prove it, we could find the magnitude of this. Let's do that just for funsies. So the magnitude of W hat it's going to be the square root of this squared plus this squared, right? Is that right there?
Yeah.
So let's say the square root of 3/5 squared plus 4/5 squared. Now you can type all that in, or you can use your brain and say this is what, 9/25?
Yeah.
Yeah.
9/25
And 16.
plus 16/25
25 25th.
is 25/25.
1 square root of 1.
Yeah. So to create a unit vector, just take whatever vector it is, divide by the magnitude. Well, we could probably make a fancy formula, huh? We could, yeah, let's do that. Let's get fancy. So a unit vector, unit vector,
Turn the page.
we could say v hat is equal to a vector v divided by its magnitude. Yeah. So this is where getting to know the notation is useful.
Yeah.
Because if you didn't, like, if you never took this class and you walked in and this was on the board, you'd be like, v equals v over v, and there's arrows and absolute values strewn about. You'd be like, what in the? But now you're saying, we realize that a unit vector is a vector divided by its own length. And you're like, oh, something divided by itself is 1. Oh, okay. So again, we're learning a lot of notation and symbols that are scary, but once you get to know it, you're like, that's not so bad.
It's like you're saying 1 equals 1.
Yeah. So, now that you know what a unit vector is, let me tell you about a thing called standard unit vectors. Standard unit vectors.
Standard.
I hat is equal to 1, 0. This is a unit vector in the direction of the x-axis
The way it is I.
because someone did it before we
It
did.
has nothing to do
And now we do it like that
imaginary.
guy.
It's not
Wait, I
imaginary.
swear.
No, it's not imaginary.
Well, that's helpful.
Yes, thank God.
Imaginary vector.
An imaginary unit vector with length 1 in the direction of the x-axis.
Now I want you to imagine a vector.
Nah, I hope you got that. No. So this is just it's just this. It's a vector that starts at the origin and it points to the right with a length of 1. That's I hat.
Wait.
Is that our written definition for it?
Well, standard unit vector. Do you want words? Okay.
Yeah.
Um,
Using all the letters.
You were almost making
A unit vector in the direction of the positive x-axis.
So that's the standard. Yeah.
And well, you already know there's a j hat, and that's going to be 0, 1.
Yeah.
And that's a unit vector in the direction of the positive y-axis.
Wait, why is it a J and a I? Because someone
Because
did
someone
it
did
before.
before we did.
Someone just decided, hey, we're going to pick.
Are those different things?
Yeah.
J and then the I.
And then
Oh,
Y.
yeah.
The switch. So that one's going to be going up.
J would just be going up one.
Yeah. I is going to the right, and then j is going up.
I is going to.
Is there
Yeah.
like negative I hat?
Yeah, you can do all that.
I.
So that's the same definition, blah, 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 in the direction of the y-axis. And the reason why people came up with this is so they could also write vectors in another way, because there's not enough ways to write it already. We write it a million different ways. But it's kind of nice, actually. You can write a vector, how do I want to say this? any vector can be written as the sum. Any vector. You'll like this, Brendan. Some good words about to come out.
Love that word.
Any vector can be written as the sum. I guess it could be difference. How about as the combination? Because that could be sum or difference. As the combination. As the combination of scalar multiples of the standard unit vectors. Standard unit vectors. What did you just say to me? So let's say we have a vector and it's 5 comma negative 2. You can write it like that. Or you can say this is 5 I hat minus 2 j hat.
Oh. So there's like a different way of writing an ordered pair?
Because this, yeah.
So it's like
Because, so you have 5,
minus 2 on the j.
think about what this looks like. You have 5 I hats, you have
Yes.
5 of these little fellas.
Oh, yeah.
Hey fella. And you're going to subtract 2 j hats. So instead of going up 2, you're going to go down 2.
Yep.
And then your resultant vector is this guy, which is v. Which is clearly 5 comma negative 2. But it's a combination of scalar multiples, so I just multiplied it by a number, scalar multiples of the standard unit vectors. So you might see it written like this, you might see it written like that. These things happen. Alright, I'm going to tell you one more thing. And then I'll stop. Make it stop. I need space.
I was crying.
No, actually, this is kind of fun.
Yeah, it's a barrage of new words and notation.
It's just like a brain
But the-
workout.
Yeah, it is. It's like high interval,
Lifting.
high intensity interval training.
Knowledge.
Ah,
Yeah, it's like
HSE. We're getting swollen. All right. So last thing, a vector can be determined by 2 points. For example, if P is a point, parenthesis, it's just a point, bless you, 1 comma 4, and Q is just a point in the XY plane at 5 comma negative 5, if that's a thing, then vector PQ, see what I did?
Yep.
Vector PQ is going to be a thing. Let's visualize this. All right, I'm going to erase this. Let's picture. I like to picture my math. 1 comma 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1 comma 4 is here, so that's P. And then 5 comma negative 5. This is Q. So a vector PQ is an arrow that points from P to Q. That's vector PQ. Oh, and we can break down the components of it. Right, I'm just looking at how far over did we go and like a kind of a rise over run thing. So what this will be is the difference of x components. So I'm going to write it as 5 minus 1. So this guy minus this guy, comma. And then the difference of the y components. So that the last one minus the first one. and this is 4 comma negative 9. 4 comma negative 9.
And what's that point? Is that like some...
What's what point? So this, okay, this is gonna bake your noodle.
So it's over 4 down 9.
Yeah, so this vector, this is just an arrow with,
ending spot? That point?
no.
Like the
So this, I'm gonna answer that question, and this is, hopefully it doesn't give you a nosebleed. This is a vector that has a certain length in a certain direction, but this could be anywhere.
Yeah.
So vector PQ could be here, or here, or here. Yeah, it's
As
bad.
long as it drops 9 and goes over 4.
Exactly.
Okay.
So if it's just a vector like that, you don't know where it is. You just know its direction and the length of it.
So what's...
What's the point? So it's
What's the point
yeah.
of the vector?
You don't know where it is, like...
Well, so there's a thing called a position vector. If someone says a position vector, man, there's so many words. Position vector points from the origin to a place. Position, right? So if I say there's a position vector, P is 3 comma 7, then this is pointing from the origin to the point 3 comma 7. But if I don't say it's a position vector, and I just say, hey, there's a vector V,
Oh, then it can be anywhere.
3 comma 7, yeah, you just know that it goes over and up.
3,7.
Yeah, and
Over
it could be
3,
anywhere.
Points
Yeah,
to
3
the-
comma 7, this means that it actually goes 1, 2, 3, 1, 2, 3, 4, 5, 6, 7.
And that would be your position vector.
Yeah, so we could call this point R. Even we could call it P if we wanted to. We could say there's a point P. So there's a point that's at 3 comma 7. So this is a point. This is a vector that points to that place. So the vector P points to the location P. This vector is an arrow that goes from the origin to this point. If we have 2 points, x1 comma y1 and x2 comma y2, then the vector is the difference. So x2 minus x1 comma y2 minus y1.
So it's kind of like a slope.
Yeah, kind of, sort of.
Okay.
So yeah, find the difference. Because remember, that's what we did here. We had to find the component is the difference.
Mm-hmm.
Yeah, if we add them, we'll get weird answers. AKA wrong answers.
Does it matter which ones? Or like Y1 and X1?
Oh, okay. So this is the tip, and this is the tail.
That's so cool.
So I did that.
Because if you do it the other way, you'll have the arrow on the wrong side. You'll be pointing in the wrong direction.
Okay.
And it matters with vectors.
Wait, but how would you know which way it's going when you just have...
Because PQ is different than QP.
Okay.
Yeah,
You gotta mind your P's and Q's.
Yeah. Hey. So what would QP? Oh, I'm sorry. This was, what did we say? It was 4 comma negative 9.
Yeah.
What would be vector QP?
Negative 9.
Negative 9 comes 4. Wait.
Negative 4, 9.
Negative 4 9.
Yes.
So this goes right and down.
And that would
This
go-
one's gonna go left and up.
Okay. I see.
Opposite directions.
Does it matter if it's x2 minus x1 or...
Yes, it has to be in that order where you start with the tip minus the tail.